you recognise this kind of table method for doing linear sequences or even quadratics? You may not have done it for the linear ones before. I presume you have done it for the arithmetic. What I thought I'd do is use it for the arithmetic as well, for the linear sequence. So over here I've got un equals, sorry about it's a bit small, but un equals an plus b. That is the general form of any linear or arithmetic sequence. You may well recognise, over here is, the y equals mx plus c. Recognise that from your straight lines? So if I change the x to an n, which you're allowed to do because you can use any letters, and change the m to an a and the c to a b, okay, and the y to a un, it all means the same thing, it's just different letters. So that's why an arithmetic or a linear sequence is the same, you get the same thing as a straight line graph. Okay? Where the grade, am I talking about things you understand here? The gradient is the same as what it goes up by. Okay? So this is what we're looking for. Any arithmetic sequence has the form an plus b. Alright? So we're looking for trying to find the a and we're looking to try and find the b. So what we do is I'm saying un is 4n minus 1. This is the way that maybe I can work out what the sequence is. Now you're going to tell me we don't need this, but we're going to use it in reverse afterwards. So I just want to check. When we substitute values in, okay, we're substituting in, I am sticking certain values of n into the equation or the formula, the explicit formula. And I start at 1 and I go 1, 2, 3 and so on. Alright, why do we start at 1 when we're doing sequences? Why not minus 2 or 0? Yeah?
Because in the sequence, 1 is like the base number in a sense. It's just 1.
And what does n? 1 means the... You're right, I think you're right. Right, it's just expressing it.
1 means the... Started...
First...
Yeah, first. No, number.
Number, yeah. When I put n as 1, it's the base, it's where you start from. You start at 1. The first number, the second number, the third number, and so on. It makes no sense to put n as 0. If I was using mx plus c, x can be any number. It can be 0, minus 3, 2.385, anything you like. But in a sequence, we're only interested in when n is 1 for the first number, 2 for the third number, 2 for the second number, 3 for the third number, and so on. Make sense?
Yeah.
Okay. So I start there, and then I'm going to do the 4n bit. So what's 4 times 1?
4.
So we've got 4, 8, 12, 16, 20, 24, 28. Okay? Now that's where we get the whole, it goes up in 4s from, because it's 4 times n. So obviously it's 1 lot of 4, 2 lots of 4, 3 lots of 4, and so on. Right? And that's where it comes from. If it goes up in 4s, it must be 4n. Because the next bit, the minus 1, well, I've written over here that an is a variable. It changes as you change n. But this plus b is a constant. It's minus 1 every time in this case. So if I do un, I want un is 4n minus 1. So I take 4n, 4, and I minus 1, and I get 3. 7, 11, 15, 19, 23, 27. So that is, that's the sequence here. Alright? How many terms have I written?
8, 7.
7. Yeah, up to n is 7. So we've got 7 terms of that sequence. Goes on forever. Okay? Alright. So, does that make sense to everyone? It's easy enough. I'm probably telling you things you already know. Are you writing that down or can I move on? Write it down. Okay, so I've written another sequence. I'm pretty sure you'll be able to tell me what the rule is anyway, but I want to go through the method. Okay?
I don't answer.
I don't want the answer right. I want to go through the method because we're going to use the method for a quadratic. Okay. So this is kind of doing it on one that we know how to do. Hopefully it'll make it easy. So what I'm going to write, I'm going to do my little table and I'm going to say, right, n is 1, 2, 3, 4, 5. Okay? And I know that it goes up in what? Plus 3. So I've got that, it's plus 3. Now, that means, because I know it's an arithmetic sequence, do you remember what I called the plus 3? It's called a... I give you a C and a D. Speak loud, proud. C stands for common, D stands for difference. So the common difference is plus 3. So that means, straight away, we know we're looking for our AN bit, because we've got a common difference. So we're looking for what is the AN. And we know straight away, if it's plus 3, it's going to be 3n. That's the shortcut way, yeah? Now we've looked at it a different way and shown how it builds up. So we're happy to go back to the shortcut method now, because we understand where it comes from. And what I'm going to write in my table is, well, what is 3n? What should it be? So 3 times 1 is 3, 6, 9, 12, 15. Okay? But then we're looking for the constant. Right? So we're looking for the plus b bit. So what's it going to be? Yeah.
Plus 2.
And how do you know that?
Well, I use the shortcut method, and since it goes up by 3, its last factor is 2.
Okay. So what we're actually looking for is, I've got 3, but what I actually need is 5. So I could say, well, 3 plus 2 makes the 5. Got that? And then I just check, does it work? So 6 plus 2 should equal 8, 9 plus, so I know, actually, yes, it's always going to be plus 2, plus 2, plus 2, plus 2. That works for them all, yeah? 15 to 17, I add 2. So then un, I know, is 3n plus 2. Okay? That's the rule. Easy, right? Good. So we're going to apply this same method to our quadratic sequences. So I've got it written over here again, so it's a bit small. A quadratic sequence is not ax plus b. A quadratic sequence will always be ax squared. That's the quadratic part of it. Plus a linear component. Actually, I'm not going to write the x. I should be writing n's. I'm getting stuff. So there's a n squared, b n, and then maybe a constant. All right. Now the constant bit, we know what. The linear bit we can deal with. We've got to work out our quadratic bits. How do we find out the quadratic bit? Yeah?
Use a quadratic formula.
Use a quadratic formula? Sorry. What do you mean by quadratic formula?
Like b plus minus the square root. I don't know.
Minus b plus minus. Actually, we don't. Does anyone know why you would use the quadratic formula? It's not for this. No? So the quadratic formula is used for solving a quadratic equaling 0. And we haven't got that yet. We've not even got the quadratic equation, so we need to figure it out. Now the linear bit, we have this thing where if it goes up in threes, we've got 3n, yeah? What we need is the same kind of idea for the quadratic. Anyone know what it is? No? Okay, good. Not good if you don't know, but good. We've got a starting point. Alright, so what we're going to do is we're going to take the most basic quadratic sequence that we have. One that we know. So if I say n is 1, 2, 3, 4, 5, 6, I'm doing 6 terms. What's the basic quadratic sequence?
N plus 1.
Nope, that would be a linear. It's on the wall in front of you. 1, 4, 9, 16, 25, 36. Okay? And how do we get that? We know that that is n squared. Make sense?
Yes.
1 squared is 1, 2 squared is 4, and so on. That's the most basic quadratic sequence we've got. So what we're going to do is we're going to look at that. If we try and do the how does it go up by, what do you notice? So it goes up plus, plus, so it's not got the common difference. Okay? That's how I know it's not an arithmetic, it's not linear, because it's not got a common difference. But this is where you might go, oh, hang on, but what do I notice? I do notice that if I take the difference of the difference, it's always plus 2. Okay? So, in an arithmetic or a linear sequence, that first set of differences, and actually I'm going to give it a name, it's the first line of difference. Okay? In an arithmetic one, the first line of difference is common. But in a quadratic, the second line of difference is the same. Okay? And in this case, it's plus 2. Always plus 2. So that makes me think, well, if the second line of difference is plus 2, I'm going to have n squared. Right? Got that? Right, so I'm going to ask you to fill out a little table for me. So I want you to find the second line of difference. I abbreviate to second line of difference. So we've done n squared. I'd like you to do, well, arithmetic we have n, 2n, 3n, 4n, 5n, 6n, and so on. I would like you to do a little investigation for me. Maybe you already know. Fine. N squared, the second line of difference, is plus 2. What about for 2n squared, 3n squared, 4n squared, and so on? Can you figure out for me what the second line of difference will be for those? Maybe you can come up with a generalization. Alright? Make sense? Everyone clear how you're going to do that? The easiest thing is, if I know that n squared is 1, 4, 9, 16, 25, but if I want to do 2n squared, I just take that line and double it. So it's 2, 8, 18, 32, 50. 3n squared is 3, 12, 27, 48, 75. Feel free to use your calculator. And then find the difference, and then the second line of difference for those sequences. And if you're smart, if there's 3 people on the table, you say no more. So we found that if it's 2n, the second difference is plus 4. 3n, the second difference is plus 6. 4n, the difference is plus 8. 7n, we're predicting plus 40, and you're right, okay? And the rule is, with a quadratic, if you find the second line of difference, you half that number, you know how many n squared you've got. Make sense? Okay, so that's the first stage done. So for instance, if we try and apply this now, if I were to give you a sequence, alright, you're going to have to bear with me, I'm going to have to think about it. Okay, so I've given you a sequence, I've given you the first 5 terms of a sequence, so what we want to do is see whether we can figure out what un is. Can we find this explicit formula? Can we find the rule for the general term? Okay, done it already?
Yeah.
Done it? Yeah? What is it?
2n squared.
It's not complete.
Oh, the whole
Plus.
So you've got the start. No, you've got the start.
Ah,
there. That's fine. Okay.
Okay.
So, first stage, I'm looking for un. Now remember that un, we've decided it's a quadratic because it's plus 8 plus 12 plus 16 plus 20. Okay, so then the second line of difference, if we know we have to go to that, we can already say it's going to be an n squared. So I can then go, right, un is going to be of the form an squared plus bn plus c. So first of all, I'm going to deal with this bit. So I'm dealing with that, and I know that if it's plus 4, okay, plus 4 on the second line of difference, so we take that, we divide it by 2, and we get 2. So that is my number of n squares. Make sense? So I've now got un is 2n squared, but there's probably going to be a bn plus c. This is where we use that table thing of going for. Alright? Tell me if I'm going too quick and you want to stop and write it down. Okay. So I know that bit, so this is what I'm going to do. I'm going to write myself, now you might choose to not do all this in the future, I'm just going to do it now to explain. So again, I know that n is 1, 2, 3, 4, 5, okay, and I'm going to do my 2n squared bit first. So what is 2n squared? So n squared is 1 times 2 is 2. N squared is 4 times 2 is 8. 9 times 2 is 18. 4, 16 times 2 is 32. 25 times 2 is 50. Okay? However, if you look at that, it's not what I want. There's still a difference. This is why it's called the difference method. Alright? So I'm now looking for how to get from what I've got to what I need. So I would need plus 2 plus 6 plus, is that right? No, that's plus 4. Plus 6 plus 8 plus 10 to get to what I need. Is everyone clear what I've done there? Because I'm looking at different parts of the page, and I appreciate sometimes that's a bit tricky to do. Alright? So this line here, this is the plus bn plus c that I need. Make sense? So that here, that I've got to add on, so that's going to be this. So I've got the 2n squared bit down, but now I need the bn plus c. So we now have what we had originally. What do you notice about that? Well, this is basically an plus b, but just with the b and c. So it's a linear, this is the linear part. So if I find out the rule that gives me these, I've got it. And what is it? 2n. So actually this is plus 2n. 2, 4, 6, 8, 10. N is 1. So it goes up by 2 every time. So I'm now doing the linear part, just like I was before. So plus 2 every time, 2n. Is there any difference with, do I have a constant that needs to be added there? Or does that cover it? That covers it, doesn't it? Sorry, I need to rewrite that. So that then leads me to my whole quadratic sequence is, well, I got the 2n squared bit first, then I add 2n. And that's the quadratic rule. Now there are other ways to do it, but that's a nice starting point. Make sense? Yeah? Like I say, I would like to talk about another option, but I'm not going to do it now, right? Sometimes there's a real quick, easy, oh, I spot that straight away, that's no problem. And I'll talk about that after you've had a bit of practice. Questions?
Is the other option easier?
It depends. Depends what the sequence is. Yeah?
Like, how do you get 2, 4, 6, 8, 10? Do you just do the n, the n, and
Yeah, so if we go here, look, I want 4, but I've got 2, so what do I, 2 plus 2 gives me the 4.
Okay. Yeah, that's
8 plus 4 gives me the,
I have another way that I thought was easier.
for this one, yeah?
Quadratic,
Yeah?
Instead of like plus 2 plus 4, and I know how you got that because like it's how much you need to add to get
Yeah.
that. But instead I did 2n squared minus un, so minus the sequence already, which gave me 2, 4, 6, 8, 10, and then plus 2, which is 2n. And then how you do the linear, you go back, well how I do it, go back, minus 2 is 0, so it's just 2n squared plus 2n.
So I think you've done exactly what I did.
Yeah, I know, but I just
Yeah,
thought
that's
it
how
was
you've done it,
easier
yeah.
to like mentally do it.
Yeah.
So it's not as
Yeah, whatever works for you. I'm happy. Any other options anyone wants to share with us where they may have done that? Similar. No? Okay.